Welcome back and welcome to Lesson 8 of the Houdini Environment Beginner Series. In this video, we're going to start with the modeling for our procedural house, and we're going to walk through a little bit about what's going on and then break down the first section of this video, which is up here, where we're going to cover how to set up a input shape and then convert that input shape into a more formal setup for what our house is going to look like. So add a few details, prepare a few of the walls for the network that's later going to take those walls and create these variations. So whether it's a garage door, a small door, or actually a wall here, which is going to be a custom modeling challenge we'll get to in one of the later lessons, actually lesson 12 here. We'll walk through how to create our own new idea for modeling that we can extend our existing house and then implement that into the scene. So you can see how you might edit and extend a network to create a new model or new parts of the model that you want to add in later. So again, as we've covered before, a lot of this network is randomized with the frame number. So if we click play and then walk through each individual frame, we can see that all these parameters throughout the network have been randomized, whether they're the size of the box, whether the shapes here are actually doors or windows, or the roof is a dome or whatnot. All of that setup was done using a few rules and then a few randomization settings. So we can have really infinite control over what we want to have Houdini do for us, or if we want to set up certain rules, we can have those also implemented so Houdini follows them exactly as we decide. So I'm going to rearrange a little bit and then we'll jump straight into the input, which takes a single box. And for the end of this lesson today, we'll probably walk through here, but we'll get past the box, a couple setups, and then we'll actually prep to see how we split out these faces into what we'll later use as individual parts. So this orange part might be a garage, this blue part might be a window, and then with each frame it does randomize what wall has what aspect of the house. So that's how I've chosen to set up the randomization, but you are welcome to modify or extend this setup to however you see fit. So to get started, this is a box input we've used. Whoops. Again, this is just a regular box. I changed a few settings for the size. I did a randomization function, which we've covered before, which is fitting the frame number from 5 to 8. I did that on the X and the Z, and then the Y I actually kept as 3. But I could change that, and then that would update throughout the rest of this scene, which is one thing I'll actually show you really quickly. If I go down to the bottom here, you can see our house is now extra tall. And if I change the input shape, which you're welcome to do, and I actually encourage you to mess around with the shape and see what you can come up with. And you can see it sometimes works and it sometimes does break. So there's some assumptions that we made throughout our setup here. So we did make the assumption that our house would be relatively the same size. So if we made this really tall, some of the functionality would break. But these are edge cases that you can plan ahead of time to have your setup work for all of them, or different kinds of inputs you might need. So if you wanted this to be a circle, you could have set that up. But the way I set it up was for it to be a rectangle and then randomized between these. So a few other assumptions down the line I make, but we'll get to those as we go node by node. So again, randomize the box size. This add was actually a way I used to place this box. So I could have done it just this way, but sometimes with a larger scene, I was foreseeing we might have maybe multiple grids, or a grid with multiple pieces. So now I'm switching for this input stream coming into the grid, place the box here. So if we were making a city, and I'll show you quickly what this looks like at the end. We might have a larger part where each individual building is connected, but it does break the setup because I was not planning on having multiple objects. This is being processed one object at a time, and that is done just with a single box. Next up, we use this match size to place it in the center. And then I do a group on the top because I'm going to scale down this front face to get those slanted walls that we can see here in this image here. And then these also were, for this video and for future videos, little previews of what the network goes on. And then inside these boxes, it's a map to where in the network each individual task and each individual lesson is actually teaching about. So feel free to jump around and explore a little bit more as we go forward. So this is split top by the normal. Again, pretty standard thing with our group create. Split bottom, and we're naming these to top and to bottom. We transform actually the bottom, so we scale it along the X and the Z. We scale it to 1.2. And then we transform the top as well. It looks like to scale to 1.1 and 1.1. So I could have just done this with the transform here and then plug that directly into here, which looks like it wouldn't have scaled the bottom. So I did it over 2 transforms. You can do it over 1 or however you choose to actually set that up. All right, now I don't want the bottom, I want it bigger. So this accidentally got disconnected. So now I'm going to plug this in to there. So that's one thing to notice actually. Sometimes your wires can be on top of other wires, but not be connected. So sometimes dragging these nodes to the side can help you see whether a wire is actually connected or if it's just underneath the node itself. And then this sort I use to resort the actual primitives. So if I click on this primitive number here and then click on W, we can see the wireframe, and we see primitive 0 is here, primitive 1 and primitive 3 is on the top. And if I play, oops, my viewport's going a little bit slow. I'm going to hide other objects just in case we're thinking about anything external to this network. So if I click play, we'll see one, the box actually does randomize based on this function here. And then also the order of our primitives is changed. So 4 is here in this negative Z direction. And then on a different frame, it's 2, and then 5, and then 0. So this is done to randomize which wall is a window, which wall is a garage. And there's a few other ways to do that, but this is the way I've chosen to do so. And then down here, I get the bound. And what I'm going to do here is I'm going to set up a Boolean. I'm going to disable these nodes, or this setup here for the numbers. But I set up a Boolean to cut into our shape and remove these panels here to get some corners on the outside. So the way I've chosen to do that is first to get a bound. And the reason I used a bound rather than a box is because if I do a box, it will give me, I'll show you real quick. It will give me actually the same size as if I do a bound, but bound has this functionality built in where we can do padding on both the inside and outside faces. And the box does not have that built in. So I chose to do the padding. I chose to shrink it a little bit by -1 in the X and Z, and then -0.2 in the Y. So you can see it's a little bit inside our original shape, which came in here. I then group the horizontal objects using a group create, group by normals, and then I do an include normals matching opposite directions, which gives me the top and the bottom. Then I blast out the individual faces for this horizontal, or these primitives, so now I only have the external sides. And then this primitive split here is actually splitting each individual piece, so then it can be displaced one by one. So if I didn't have this primitive split, these corners here would be connected. But what I want to do is I want to split them here, so you can see each individual primitive is being split. And now there's 16 points, but before the split, there was only 8 points. So we're splitting these up to allow us to then separate these. And then this ray function is this ray node, excuse me, is a really helpful thing in Houdini, which allows us to displace geometry, and I'll connect it here, either along the normals or maybe the minimum distance to here. And you can see this ray now is snapping these primitives to the nearest point on this incoming geometry to the second stream. And in that case, it is up here. So it's pushing them upwards. But what we want to do is project the rays along the normals, which will take these rays and then push them along the directions of their normals until they intersect this incoming geometry, which is this wall here. And it looks like my Houdini is a little bit slow, so I'm actually going to pause and restart to hopefully clear that up. So I'll be right back. All right, welcome back, and we are going to continue. That was just a quick computer restart and Houdini restart to hopefully speed up our seeing view just a little bit. So I'm going to get back to our lesson slide here in the bottom right. And then again, this is the same network, just a different view. And I've done that so I can see these lesson slides while also reviewing our actual node network at the same time. So to continue what we were doing, we learned that our ray node here is actually being used to displace these points along their normal until they intersect with this target geometry or collision primitives here on the second input. So that moves these, which we've split with our primitive split, to intersect with these external walls here. So same exact setup there. I can even connect this and delete this node, which was the original one we had. Now what we do is we peak, so we displace again along the normals, and peak we've learned about before. It displaces along the normals in a constant amount. So rather than a mountain or another node similar to that, we displace here, and we could also do this, and I'll actually show you, with a wrangle. Whoops. If I can connect these two. So what we want to do is we want to displace these points along their normal by an amount of negative 0.25. So with the wrangle, what we could do is we could do v at p, so our position, plus equals, which is vex for equals v at p plus. And now what we want to do is we want to take the normal, which is v at n, and we want to multiply this by negative 0.25. And this does that same exact thing as peak. One thing we should actually be aware of is v at n is the normal direction of our points, and this is currently normalized, so the length of this normal vector is set to 1. This is also the same as v at p plus equals v at n times negative 0.25. You can see same exact functionality down there. But what I wanted to mention is that v at n, we're assuming that it is normalized. So we're assuming the length of this n, this vector, is 1, which in this case it's true because Houdini is calculating that for us. But if you are doing displacing along other vectors, you want to be aware of the magnitude of the vector you're multiplying by. So what we could do is normalize this vector before we multiply it by negative 0.25, which would then just assume or ensure that actually that the direction is maintained, but the scale of this vector is always equal to 1. So that would be a good practice to at least be aware of while we are displacing with normals. But the peak also does the exact same thing in this case. So we poly extrude 0.5 again along our normals, which Houdini is computing here for us. And we want the front and the back of these faces of this object because we're going to use that to Boolean. And now if we connected this here to our Boolean from this internal shape, we'll see we do get a cut, but not the cut we wanted. Because we want to have, I'll actually set this to wireframe so we can see a little bit better. We want to have these cuts here extend up to cut through the roof or the top of this building and the bottom of the building as well. So the way I've chosen to solve that problem is I group these objects by the normal. So I pick up and down objects and I use a spread angle of 20 degrees. So I can get these slightly slanted normals here. So they're not directly down in -1 or +1. They're within a margin of error of 20 degrees for those angles, and we'll group those together. And then again, we'll peak, but just this horizontal group, which we've just created here. So this moves those normals, or these object faces, these primitives, in the direction of those normals. And then when we connect that to our Boolean, we get the correct result we're looking for, which is to remove this top area and this bottom area from the building. And then this on the other side, I'll just show you really quickly, was a variation I added for if we wanted to cut these vertical corners as well. So you can see toggling the switch between 0 on the left and 1 on the right lets us choose between which of these two we want to keep. And the way I made these extra tall points here was I got our object, this input shape. I grouped by normal, so I picked only the bottom, the base of these, removed everything else with a blast, so space G to frame. Add, I actually want to keep just these points. And then I want to copy this really tall box here, which I've set with the box. I want to copy it to those points, merge it with this shape we created, and then Boolean, so I'll switch it to 1, with this shape here. And then this add I actually don't need. It looks like it is having me need it. In the way I could fix this, actually what's going on here, this add is removing these points, and it looks like Houdini is then recomputing the normals internally to give me the correct orientation that I'm expecting. If for some reason I didn't want this add, what I can do is fix this, and the way I can fix that is by setting this normal. Let's see if we can guess ahead. So Houdini, when it does copy to points, it instances the positive Z direction, so it looks like this direction, along the normal of our object. So if I set this normal, v at n equals 0, 1, 0, so the positive direction, it'll do nothing because that's what Houdini's already doing here. But if I set it to a different value, so 1, there we go. Now it's saying the normal direction for this incoming object, we can see here, should be along the positive x direction. And then we're saying take the positive z direction here from this input object and align this positive z direction towards this blue line here, which is our normal. And then when I do that, it gives me this same result. So I'll just leave it like this. We could actually put that wrangle back and then remove the add. So either of these ways work, and I just want to tell you that the normal attribute is important for the z, the positive z, when you're copying points. And this will be important later once we start instancing in Solaris. We want to have our objects, our rocks, our pavers, and our little grass. We want to know and be able to expect and manage the orientation of those objects. So we'll leave these pillars here for the Boolean. I'm going to disable this preview of our normals, and then we'll keep going. And then one more thing actually for the Boolean. This I have mentioned, but it is important to know. Since these two are solid objects here, we want to have our Boolean set to solid and solid. Surface might give you the correct results, but it also might not. And Booleans in Houdini are powerful, but a little bit finicky, so they might not work the way you expect. So just check to make sure that your geometry you're actually cutting with is correct and does what you expect it to do. So next up, we create a group again, which looks like we're grouping by the normals, so the positive and only the positive. And I could actually rename this to top group. And then when we inset, we are insetting top group. So maybe this one wasn't actually needed, because it looks like I'm actually insetting this group up here above. So we'll inset that with a negative value to give it a little bit of a bevel on the outside to extrude past that top of the building. We'll extrude that upwards, again with another poly extrude. We'll inset that, and this again we've covered a little bit in our procedural tower setup. And then we'll extrude that one again. Inset that one again, and then we'll do one more extrusion. So this set of nodes here just adds this little detailing and these little ridges at the top of our building, which will then later be smoothed with some VDB remeshing to give us that smooth area in between each one. And this I was just splitting because I was actually going to use this part of our object later to scatter some of these little wooden planks that we're creating as like internal support for our roof. So then back up here to extrude, we're going to continue going down, and then this finishes the base of our building. So we take this input shape here, run all these operations, all these nodes, and then get this base building here. And if we click play, we can see all the different variations that Houdini is creating automatically for us. Now, before we pause this video and go into the next lesson, I want to show you the setup we have that's later going to be feeding into each one of these walls and then later creating each one of these individual parts of a building. So here, we take a measure node to measure the area across each of these primitives, and we're coloring that to preview what the area looks like. You see this does the same thing. And on our primitives here in our geometry spreadsheet, we can see the area for each of these individual primitives here. And what we want to do is we want to keep the really big ones, and we're going to say we want to keep the ones that have an area bigger than 5. And I've used this color node here to preview which ones are bigger than 5 so I can actually visualize which ones I want to keep. So by sliding this ramp input, I can change which values here are being remapped to which colors. And 5 was a value that I found across all of these randomized sizes that would give me the top of our building as well as the 4 main walls of the building. So then I'll group by horizontal. I split, so I actually don't need these roof and bottom anymore. And then what I want to do is I want to randomize these because I want to say, okay, Houdini, randomly pick each side and maybe make it a garage, make it a window, and then I'll let Houdini decide which one is which. So this is done with a sort node. If I let it think for a second. And here we're just sorting primitives by random. And then we are assigning a seed of $F. So then every frame, that's points, every frame we get a new primitive number for each primitive. And then here what we've done is we've set a ID based on the primitive number times a seed, and then we've done a random color from the ID attribute. And this was just a way to preview different colors, and I actually used this to set up the next set of slides for this video down here. So that'll come in the next lesson, but we now have access to random primitives, on this object, and we're able to use, for example, this one we split out, and primitive number 0 is always going to be, it looks like a door. And then we'll split it out here, and it looks like we have primitive number 1, which is being now renumbered because it's the only primitive. But this one is being split and say, okay, take primitive number 1 and always make it a garage door. And then here we're taking actually the other 2 primitives, which is now 1 and 0 because it's been renumbered. But from this input split geometry, it would actually be 0 and 2. So those 2 ones on this side here, those are being used to actually randomly select again between, looks like a window, and then this is actually the, I believe it's the garage. Yep, looks like the garage. And then there's another one where we're going to randomly select between a new modeling challenge we'll create together. So that'll end currently this lesson, and we're going to jump into the next one where we will actually start with creating this framing, the roof, the human door, and then the garage door, and we'll get further into the modeling and keep understanding exactly what's going on with this network. So awesome. Thank you, and then I will see you in just a minute in the next video.